right, let's take a look, guys, at section 5.4, which is on a topic called the average value theorem for integrals. And we had the average value theorem or the mean value theorem way back in chapter, I think it was chapter 4 for us early, where we looked at the mean value theorem for derivatives. But now we're going to look at the average value theorem or the mean value theorem. It's really the same thing for integrals. So a lot of times I use those words interchangeably. So the average value of a function is the value that would give us the same area if the function were a constant. So in other words, if I take a look at this function, y equals 1/2 x squared, and let's suppose that I wanted to look at the integral of the function 1/2 x squared dx from 0 to 3. Let's just start with that. So visually, of course, we know that that would be the area under the curve between 0 and 3 in that first quadrant. Okay, well, think about kind of like how you would do an average in your stats class, for example. You would take the total, you would add everything up, and you would divide by however many items were in your data set, right? It's the same idea. So this is the total area under the curve, right? We know that. Well, since it was over an interval that was 3 units in length from 0 to 3, we would just divide this by 3, and that's going to give us our average value. And so the formula, if you want to remember this, is the total integral from a to b divided by b minus a, the width of the interval. In this example here, let's just work this out and see what this gives us. 1/2 x squared becomes x to the third over 3, but then times the 2 in the front gives me x to the third over 6 from 0 to 3. And then, of course, over the 3 that's already there. So let me come down here. That would give me 3 to the third over 6 minus 0 to the third over 6, which would be 3 to the third is 27 over 6, and then of course dividing by 3, so that would be times the reciprocal 1/3. Let me reduce this out. Let's see, that'd go 1, so that would go 9. So this gives me 9 over 6, which simplifies to 3 over 2. So 3 over 2, or 1.5, would be the average value for this particular function over the interval 0 to 3. So graphically, that would be at 1.5. That's what they mean by a constant. You don't have to remember this definition per se. Just note that it would be right here in the graph. And notice that the curve itself intersects with that value, that average value of 1.5, right about there, somewhere in the interval between 0 and 3. And that leads us to something called the mean value theorem or the average value theorem for integrals. So it's similar to the one we did with derivatives, sort of the analogous version looking at areas. So it says that as long as we have a continuous function at some point in the interval from a to b, so like in this example from 0 to 3, there is a place where the actual value, so that would be the actual value of 1.5, will equal to the average value. So in this example, that happens somewhere between 1 and 2. So somewhere between where x is 1 and 2, the function itself has a value that's equal to the average we got of 1.5. And so here it is kind of summarized. If f is continuous on a closed interval from a to b, then at some point in the interval, f of c, the actual value for the function, is equal to the average value. How would we work this out? So in that last example, notice that our average value that we calculated was the 3/2, or the 1.5. So we would set that equal to the value, or set that equal to the function itself. Now the original function back here, remember, was, where was it? It was 1/2 x squared. So I'm going to set this equal to 1/2 x squared, and I'm going to solve this equation to get this particular c value, or this location where that occurs. I'm going to multiply both sides by the 2's to start off. So that means I have 3 equals x squared, and then I'm going to take the square root. I get x equals plus or minus the square root of 3. The one that I want in this case is the positive, so that would be the positive root 3, which is about 1.73 to, I don't know, something like that, square root of 3. But here's what I want you to observe. That number right there that we just calculated, notice that that would be right here. So it is actually between 0 and 3, and it's about where I drew the arrow, somewhere between 0 and 3, about 1.7-ish. That's where the function value, so f of radical 3 was equal to 1.5, and that occurred right there. So the theorem says that at least at one location there will be a place where that x value gives us a corresponding y value that's equal to the average. All right, so this may sound a bit complicated. I get that. This is a little bit high level of a way of thinking about it, but once we do some practice, the computations for these are not too bad. So bring your notes with you and we'll take a look at these in class tomorrow.